Hello. Welcome to this demo on a bin-to-bin offline app. Bin-to-bin is a warehouse management transaction wherein um, a quantity of product is moved from one bin to another. And we have taken this use case to demonstrate what offline means or what offline processing means in app development. So firstly, let's talk about the basics. On the left, you see is all the characteristics of an online SAP application. On the right is offline. So online applications are always online. So if the moment you lose your network connection, you're basically connected off, and you cannot process any transactions when you're offline. And this also is referred to as stateful applications. The data is not stored when you're working online, is not stored on the UI layer. If you're logging on through either SAP GUI or from a mobile application, the moment you lose network connection, nothing is stored on the UI layer, and then you have to start all over again. The data, therefore, when you're connected online is always current, and there is no it's either on or off, essentially. If you're off, nothing happens. If you're on, you're always current. So whatever you get from SAP is always the current data set. And therefore, it doesn't require any syncing logic. On the other hand, the offline application is, so when we say offline, it essentially means offline also. Fundamentally, every application, the goal of every application is to be able to update data into SAP. So if you're completely offline and never go back to being online, your data will forever remain in the device and you're not updating anything in SAP, and therefore, what's the point of that? So it's these applications can work both online and offline seamlessly, and the data is stored on the UI layer, either on the browser or the mobile device. And because of this reason, the data on the device may never be current. So if you're processing something offline and it's been 6 hours since you actually synced, so the data on your device is stale by 6 hours. So the syncing logic needs to be built in the mobile application so that the data from the device can be synced back. So when we say sync back, it's a two-way process. The data from the device needs to be updated in SAP, and the latest data, either metadata or transaction data that you need for further processing on that mobile device, needs to be retrieved from SAP to the mobile device. So it's a two-way sync. Okay, with that out of the way, let's talk about the main design elements of an offline app. So because of the fact that the data is stored on the UI layer, you need to actually design the table structures along with keys and how the data is related to one another on the device. So you have to replicate part of SAP on the device. And this is where it gets tricky because the SAP data model is infinitely complex. So there is a point beyond which it may not make sense for us to design there is a cost benefit involved there. If you try to replicate all the logic and all the data structures in the offline application, it may take a long time. So that is something to be kept in mind. And the second thing is, once the data is stored offline, the user needs to be able to modify the data that's stored on offline, and needs to be able to actually view the data that's stored offline. So you need to have a mechanism to view and modify the offline data. The third and probably the most important thing is, how do we design a sync process? And this, more often than not, is there is never a clear answer to this. It all depends on the type of connectivity and the duration that the device is offline. More often than not, a manual trigger followed by a prompt from the mobile application is probably the most appropriate trigger for syncing. So the user goes offline, and then he comes back online, he syncs it. Sometimes he forgets to sync, but he's still online. So when he's online, the app essentially prompts the user to say, that there is offline data, do you want to initiate a sync? So that is one of the key aspects of designing an offline application. The fourth aspect is clearly once the sync happens, you don't want any residual data that has been synced to remain on the device. So you need to be able to actually delete the data on the device, and at the same time ensure that all the data that's been captured on the device is actually synced back to SAP, which brings us to the fifth point, which is, let's assume you have 4 records offline, out of which 3 records have been successfully updated and posted. One record actually has errored out because of any number of reasons. Okay, and once the data is errored out, you obviously, what do you do with this error data? Do you want to hold it on the device? No, you don't want to hold it on the device because you've already been online. This data has been sent to SAP, and you want to actually delete all the data on the device, but you don't want to lose this data because it's an error. So this is where a fail-safe mechanism needs to be developed, and this is one of the key elements of ensuring that we don't lose data that's captured on the device when it errors out. So we develop a fallback mechanism wherein we have a custom table or any data store that actually takes this error data and updates it in SAP, so that somebody can take a look at this data and then figure out whether to reprocess it, whether to delete it, because there is no clear answer to how you can handle this. So here there needs to be a manual override and a supervision requirement. So that is one of the main things of designing an offline application. So with all this in mind, our application that we have built has these steps in the process. So before I jump onto the application, I want to just talk about the main steps. So the first step is the mobile app is launched. So the user accesses the launchpad and then accesses the tile in the application. When this happens, all the data that's required for creating data on the or capturing data on the mobile device, the lookup data for bins, materials, and so on, is downloaded from SAP to the device. Then the device goes offline, and the user then posts transactions in offline mode. So when the user posts transactions in offline mode, obviously, then the data doesn't get updated in SAP, it gets saved to the device. And at some stage, the device comes back online, and then the device data needs to be synced to SAP. Once the device data is synced from SAP to, so synced from the device to SAP, the offline data store needs to be cleared out. So the offline data on the device needs to be deleted. And if there is an error with one of the, or with any number of records that have been synced, then those error records need to be created as it needs to be updated into a custom table in SAP. So that's kind of the process or the number of the steps in the offline app process. So this is kind of what we're going to demo in our application. So that's going to be our next step. Okay, here we are. So this is the mobile application. So I'm going to access the mobile application. The splash icon is showed momentarily, and then I log on. And the app is now online. So I'm going to just look at the offline data. There's nothing there, and then the app is online. So now if you just look at the app very quickly, you'll notice that there are only 4 fields that the user needs to capture. So this is bin to bin transfer. So when you're transferring data from one bin to another, the 4 main elements that that needs to be captured is the product of the material, the quantity that needs to be transferred, the source storage bin, and the destination bin. All the other important parameters for updating the data into SAP, like the warehouse number, plant number, storage location, etc., are defaulted from the user parameters in the user master. If these values are not set up in the user master, this app will actually prompt the user to enter these values by opening this pop-up. when the application is started. So that's how this has been designed. So the point is to not replicate exactly field for field, screen for screen what's in SAP, but it's to optimize and make the whole app efficient. So there needs to be fewer clicks and the input needs to be easier. So that's part of the app design as well. So now I'm simply going to, it's a simple app. Um, I just chose the product, I chose the transfer quantity, then I chose the source pin, and then I chose the target pin. And then the app is online, I'm saving it. As you can see, the data is stored offline. So this app has been designed so that all updates are done offline only. It is possible to design the application to update online if the device is online and only update offline if the device is offline. Slightly more complicated, but that's possible. So what I'm going to do here, I'm going to actually update the quantity. Just to show you that it's possible to update the data offline. Then what I'm going to do is I'm going to go offline, go into airplane mode. Once I go to airplane mode, the little red icon appears to the left of the user image, and that indicates that the app is offline. So now I'm going to go to the second one, 2 done, 6. And this is the second transaction. So now if I go back, I can see that 325A, 326A. So there are 2 records that are in offline. So from this page, the user can either go to delete mode, be able to delete it, or the user could sync. So now let's see, the app is offline. Let's see what happens when the user tries to sync. Essentially, the app informs the user that the sync is not possible at this point in time because the app is offline. So now let's assume the user has done all his transactions for the day and the user exits the app, and then the next day he comes back in and the app is online now. Okay, so now you'll see that I'm back online and I'm actually trying to sync the data. The user essentially enters the application, accesses the application, and the application detects the fact that there is offline data and that's not been synced. And then it also detects the fact that the app is back online. So it prompts the user to say, do you want to sync now? So then we say yes. The app then successfully syncs the data on the device with SAP. And you can see that there are 2 transactions, 2 records created in SAP. So we're going to log on to SAP to have a look at these 2 transfer orders. That's the next step. Okay, so we are in SAP now, logged on to SAP. I'm going to just access transaction LT21, display transfer order. And 609 was the one that we saw, first transfer order, SD32A, source data from 916D1 to 916D4. And it was done on 18th of March and by my user ID. So that's the first one. The second one is 610. So this is SD326A from 916 out zone, 2 pieces to destination 916D1. So that kind of closes the loop on how the data gets updated into SAP. If there are any error records, then those error records will get stored in a custom table. And I'm going to quickly access the custom table now. So this is the custom table. And then there are so many records here. So if I just were to look for error records that have been created in the last week, then I would get a list of error records that have been stored in the system. So from this point onwards, there needs to be a process from inside SAP to figure out how to deal with these error records. And that could be an automated process, manual process, or some combination thereof. So that's the end of this presentation. Thank you very much.